Longest common prefix, Leetcode 14. It's an easy problem. Let's get started. Write a function to find the longest common prefix string amongst an array of strings. Okay. There's no common prefix, return an empty string. Okay. Strings, flower, flow, flight. Share. Okay, so common prefix is just a prefix that is shared across all the elements, all the string elements in the input array, strings. Okay. And this is outputting empty string because, okay. Okay, then there's some constraints here. And they say this only going to consist of lowercase English letters. Okay, cool. I don't think I'm going to need all the PDAC steps here that I'm using, but yeah, we'll just, we'll work through it. Okay, so our input here is just going to be an array of string elements. Okay, and they say that it's always going to be it's always going to have something in it, so it's never going to be an empty array. And the individual elements themselves can be empty strings. So in which case, if there's ever, it seems as though I can make the assumption that if there's ever an input with some element that is an empty string, then the only possible solution would be an empty string being returned, because as far as like a prefix goes for that word, like if we were thinking like the inputs like this, something like hi, hill, and then like hillbilly, and then we had like an empty string, and let's put this one at like position 1, empty string, like there. As soon as we encounter this, we can immediately return the empty string, because we know that there's never going to possibly be any shared prefix, right, if it's an empty string. Okay, and then as far as like our requirements, I guess this is more of like just like a rule here. The input elements will always be lowercase English letters. Okay. And I guess like if we're thinking edge cases, like I guess there's the possibility of single element array. So that would look something like just like this. Hi. And so I think that the shared prefix there is just the entire word itself. And this is also sort of an edge case. I'll just grab these guys. Yeah, so we'll just paste them down there. And so single element array, empty string element. So that was this test case. And let's think, what are some other situations that could get us in trouble? I mean, they say that only lowercase English letters, so I don't think we have to ever worry about spaces. We could, but I don't think the problem really asks for that sort of coverage as far as ensuring a specific type of input. I think we can just expect that it will ascribe to these constraints. Okay. It can be empty strings, they're always under 200. Okay, cool. So for, I guess, we can just grab one of the normal cases. And we essentially just want to return like either empty string or the longest shared prefix. Okay. How do we want to do this? What makes the most sense? Is there a way to do this without? Well, since the words are all going to be fairly short and the input array is always going to be fairly short, I think going O of n squared is okay. Yeah, I think that would be okay. So I think as far as like general like steps here, I think we first want to and before we do anything, we need to check its length. So guard for input array length 1, guard for input array elements having or being empty string. So those are both of these two edge cases. And then for both of those, the like return would just be empty string for either of those. Will I guess return either input 0 or that. So input 0 for this test case here, and then empty string for this test case. Okay, so those would be, I guess, just some early return situations. And I think it makes sense to, do I want to loop across? It seems like we just want to loop across all the elements at like the first character. So like we want to loop over this like, okay, F, 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 L, L, okay, and then L, and then, okay, so then I think every time we reach the end of the array, and we have, found that every element in the array up to that point has the shared, the common prefix. And then we want to, I guess, update some value, right? So this would just be like maybe current longest prefix or something. And then as soon as we reach okay, and then that could be, you never want that to be outside of the range. Okay, so, let me just check my time. 8 minutes, okay. So I think it actually makes sense to get the shortest word first, because yeah, I think the longest prefix, or I guess longest common prefix, can never be longer than the shortest word. Shortest word in input array. Okay. So like for this example here, actually let's do this example. The longest common prefix can never be longer than high. And again, this is not, I'm using this example without that. Maybe we can just grab that and yeah, okay. So something like this. So if we're thinking about like this test case, the longest common prefix can never be longer than high. So I think we need get high first. Get the shortest possible word. So I'm wondering, maybe, I guess that's the maximum amount of letters we would want to survey. Okay, so I think that makes sense. So I think we need to get shortest element in input array. Okay, so I want to get the shortest element, and we could probably do that by sorting. Yeah, I think we can get that by sorting. Yeah. Yeah, okay, so we get that by sorting by length, and then whichever direction we're sorting, so ascending or descending, just get the first or the last element. And once we have that element, then I think we want to traverse. So I think we need to, let's see, how are we doing this? Okay, so yeah, so I think we're doing nested for loops here. So we need to get the shortest element of the input array, and also get length of shortest element. So we actually don't care about like the specifics of the shortest element, like what it is. We just need its length. So that's going to be the condition, the break condition for the outer for loop. So yeah, so get length of shortest, and then use this number as end condition for outer for loop. Outer loop, okay. And then I guess for each iteration there, the current value of this outer pointer is the current index that we're going to be checking. Okay, so I think I need to declare current longest prefix. Okay, and then we need one that is like dynamic. Yeah, so if every I think we can use every. Yeah. Yeah, I think we can use every. Okay. So I'm gonna move this guy down here. Okay, so if okay, so for this example, we have high, right? So that's so we're going to loop twice at most. And if every element if the ith element, or if the element at whatever index we're currently at is all the same for every element in the input array, then we can add that element, or that string, to our longest prefix. So this can just start out as an empty string. And as we move through the loop, we're just checking to see if every element has that specific character at that specific index. So we're getting the length of the longest, and we're using this num as end condition for outer loop. So okay, and as soon as current element at this index, so at whichever the current index of this is not equal to that element in the shortest element in the input array, then we want to break and return the current longest prefix. Okay. At current index is not equal to current character in shortest L, shortest word maybe. Then we want to break and return current longest prefix. Okay. And if we get to the end and they're all great, then we just want to return current longest prefix, which will be whatever the current value of current longest prefix is. So if every current element is equal to current character in shortest word, then we want to add current element to current longest prefix. Great. Okay. So if we're gonna like just work through maybe this example, let's do like hill. Let's maybe do that. Yeah, HIL, HILLL. Okay. I don't know why I'm using this word specifically, but anyway. Okay, so for this test case, it's the input array length is not 1, and there's no elements which are empty string, so neither of those conditions are being met. So I'm moving down to here, line 33, declaring longest current prefix to an empty string, get the shortest element. So the shortest element here would be hill, HIL. So use current shortest, or just shortest, shortest, and that's going to be HIL. Okay, and shortest ling is going to be 3 because we're getting the length of this element, and then we're going to essentially be looping over these elements. And so for all the elements at index 0, are they all H? They are. And so we're essentially comparing this element in the array to shortest at the specific index that we're at in the outer loop. And so they're all H. So then the current longest prefix is going to be H for that iteration. And then we move to the next index. So index 1. H, so then it's I, so we're good. All of them have that element at that index. So now our current longest prefix is HI. And then we move to the next iteration, HI. So then we're at index 2. And we're checking L, 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 L. They are all L. So we add that character here to the current longest prefix. And now we would essentially just end our iteration because we have reached our end condition. So now I would be 3, and so that would be no longer less than our end bound for the outer loop. And we would just return the current longest prefix, which is HIL. All right, that seems like a good approach. So I'm gonna get rid of this stuff, and we can start coding. Okay, so let's get those guard clause information stuff out of the way. So just input array length of 1. So if strings length is equal to 1, we just want to return strings at index 0. And then if some element, so if strings, some element, so some word in strings is equal to empty string, then we want to return empty string immediately. Okay, so we've got our guard clause out of the way here. Now we need to declare current longest prefix, current max, or current, we'll just call it current longest prefix. Okay, and initializing it to an empty string. Now we need to get the shortest element in the input array. So we're going to sort by length. So just this is O or N log N, O N log N. Okay, so that's the time complexity for our sort algorithm. So we take our input array of strings, sort, and we need to do sort A, B, and I think, yeah, so I think we want A length minus B length, and we're just going to initialize this to initialize a variable, or declare a variable and initialize it to the return value of this at the 0th index, const shortest equal to this. Okay, so that's going to be our shortest element, and I just want to return shortest I want to see to ensure that our code is working. I just want to inspect what it's going to return here. I'm expecting flow. Yeah, okay, flow, and then yeah, okay, cool. So that's like what we expected. That is the shortest element. So we verified that our we're actually getting the correct element. So we have shortest. Now let's just get maybe our end, and that will just be shortest length. Okay, so we're just gonna use that in our for loop, our outer for loop, and we're just gonna use for let I equal 0, I less than end, and then I plus plus, so incrementing just as a standard for loop. And if we look at our algorithm, we want to check to see the current element at the current index is not equal to that break and return. Okay, so if and maybe we'll declare another variable here, I, okay. So if strings I, oh wait, if current character or current character, yeah. So the strings I, that's actually the word. Okay, so we need current character in shortest. So actually current there, so it's going to be shortest at index I, so current character. So then if, and then I guess we can just do const current word, and it's going to be strings at index I, so whatever the current word is. No, it's not that. We don't want to do that yet. So if TRS every word, okay, here it is. So if every word in strings at the specific index is equal to current character in shortest, then we want to return true. Okay, so if every character in word at that index is equal to current character, if this is the case, then we want to add current character to our longest or current longest prefix. So current longest prefix, you just want to concatenate it to current longest prefix, so current character. Otherwise, so if every character is not, so if every character in the current word is not equal to, sorry, if every character at the specific index that we are at is not equal to the current character in shortest, then we immediately want to, else we want to break out of our for loop. And we want to actually, let's just, yeah, return current longest prefix. Prefix. All right, and then get to the end. Made it through, haven't on this condition. Then we just want to return current longest prefix. Great, okay. That looks good. All right, let's submit. Let's see how we did. See if it passed all the test cases. And it does, and it's very slow. But we did it. I'm sure there's an optimization here. Wondering, yeah, I'm wondering where it would be. It'd probably be, well, I mean, it's definitely in here somewhere. I'm wondering, yeah, let's take a look. But yeah, this was longest common prefix. And yeah, it's about 25 minutes. Kind of slow, kind of sloppy. Hoping to do better next time. But yeah, thanks for watching. Bye.